Okay, so this next video, and this is the last one of the series, this is the third video for Unit 3A2. In it, we're going to use it to find missing angles on right triangles, and this is super simple. So let's say, I've got a right triangle here, right, and I don't know what theta 1 nor theta 2 is, right? Um, so let's say I want to find theta 1 first, right? The process isn't much different than regular trig. We're going to have to use arc trig to find missing angles, right? Uh, because that's the inverse of regular trig. We know all three side lengths, right? We're not looking for missing side lengths. We're looking for missing angles, right? So to find missing angles, well, that goes back to what we were doing in the previous video. We would use arc trigonometry, the inverse of regular trig. So that said, let's say I wanted to find theta 1 first. So that's kind of your first step, is to pick which angle you want to find, right? Just like in the other process, the first step was to always pick which angle you want to use. Well, we're going to pick which angle we want to find. So we're going to look for theta 1. The next step is to pick the side lengths that either you're given or that you want to use. And in this case, we're given all three. So let's just say I want to use the 3 and 3 square root of 3, okay, just for funsies, right? So that would be opposite adjacent. Well, we know that that's tangent, so we would say the tangent ratio of this angle, theta 1, that we're looking for must be equal to opposite over adjacent. And of course, we see the 3's will cancel. And of course, we cannot have an irrational denominator, so we need to fix that by multiplying by the ugly number top and bottom. And we see that we get square root of 3 over the square root of 9, which of course is just 3. So what we've really got is tangent theta 1 is equal to square root of 3 over 3. Well, we know this from our trig table, right? So doing quick algebra, we do the arctangent of both sides, and we get that theta is equal to the arctangent of the square root of 3 over 3. Looks real familiar from our trig table. We know that theta 1 must be 30 degrees. So now I know this guy is 30 degrees. This guy obviously is 90. So that means theta 2 must be 60. And I've got it. Okay, let's do another one. So let's say this time I want to find theta 2 first instead. Who cares, right? And we're also being asked to not only find the angles in this problem, but to find this missing side df. And we can easily do that. We'll get to that. So what I'm going to do first is find my missing angles. So theta 2, right? Well, we have to take the two sides that we're given because we're only given two sides. Theta 2 has an adjacent and hypotenuse, right? Well, obviously that means cosine. Cosine of theta 2 is equal to adjacent over hypotenuse. Okay? To solve for theta 2, we're going to do just like we did in the previous video. We're going to take the arc cosine of both sides, which of course gives us arc cosine of 11.314 over 16. Now, off the top of our heads, we have no idea what that is. So we're going to use our handy-dandy calculator, and we're going to say arc cosine of 11.314 over 16. And we get that it's really, really close to 45 degrees. In fact, for all intents and purposes, it is 45 degrees. We're just going to say theta 2 is about 45 degrees, which means theta 1 must also be about 45 degrees. Which means what kind of right triangle is this? Well, obviously it's 1-to-1, but let's pretend we weren't that smart. So if we wanted to find the missing side length df, like we're being prompted to do, we have options. We can use trigonometry. I can use cosine of this 45, for example, equals adjacent over hypotenuse. Or I can use the Pythagorean theorem. Leg squared plus unknown leg squared equals hypotenuse squared. Okay, doesn't really matter. I'm going to go ahead and just use trigonometry. I'm just going to say cosine 45 is equal to adjacent over hypotenuse. Well, cosine of 45, that's a special angle, square root of 2 over 2. Cross multiply and do the algebra there. So 16 square root of 2 is equal to 2 df. Divide by 2, we get 8 square root of 2 equals df. Okay, well, shouldn't that match what this is? Well, let's see what the calculator tells us. Okay, so the calculator is going to tell us, if only I could move this over without it being stupid. Yeah, I just can't. So if I do 8 square root of 2, holy dog crap, I get 11.314. Okay, so we get the same thing either way. Okay, let's do one more just for this video. So this one's a little bit different. You'll see why here in a second. So let's say I want to find theta 1, right? We're being asked to find both angles and this missing hypotenuse this time. Okay, so I can go ahead and use tangent theta 1 because I've got opposite adjacent. So 4 over 12, well, I can reduce that just for the sake of reducing. So I can say tangent theta 1 is just 1/3. Then I can do the arctangent of that. Now, 1/3 is not a special trig ratio. It's not relative to a special angle, so we have to use the calculator again. So arctangent of 1 over 3, that's 18.43 degrees thereabout. So this guy here is about 18.43 degrees. Okay, which means theta 2 must be, so I'm just going to do minus 90, because we can just add and subtract from 180, right? So 71.57 degrees. 71.57 degrees. Now we just need to find this missing hypotenuse, this guy right here, right? And I'm just going to use the Pythagorean theorem just to prove a point. So leg squared plus leg squared equals hypotenuse squared. Right, so 144 plus 16 is equal to our hypotenuse squared. 144 plus 16, that's 160. And we know we're going to take the square root of that after. Let's just go ahead and quit playing. Okay, so square root of 160, I can just chuck that in the calculator. So that is going to give me, let's see, brain fart, 12.65 thereabout. Now, we could simplify this radical. Okay, so we can say that this is, let me think, 40 times 4. Well, let's just use the tools that we've got. So if I hit menu, let's see, number, factor, 160. So we have 2 to the 4th power times 10. So 2 to the 4th power times 10, right? And let me show you what it is I'm doing. So we've got 2 to the 5th power. So that right there is just 32 times 5, which of course is equal to the square root of 16 times 2 times 5. So we can say square root of 16, square root of 2, square root of 5. All that said and done is going to give us 4 square root of 10. And if I chuck that in the calculator, 4 square root of 10. Okay, we see that we get the exact same number here as we did here. Okay, so this would be a precise answer. Not going to be too picky about that, though. Okay, so that's all I got for this video. That was the last one of this series. So like always, if you need anything, shoot me an email. You know where to find me. Goodbye.